Hello friends, welcome back to our channel. So today we'll discuss about one more concept in compiler design, that is annotated parse tree. So already we have seen one example of how to construct the annotated parse tree from the parse tree. Alright. So the main difference among the parse tree and annotated parse tree means, so giving the attributes for each and every node in the parse tree will becomes the annotated parse tree. So the attributes may be the value or the type or memory, etc. So in this session we'll see one more example for that annotated parse tree. Yes. So annotated parse tree. So today we'll see the example for int a comma b. So the input string is int a comma b. So for this particular input, we'll see the parse tree. First, let us see the productions. What are the productions? The productions to validate this particular string is d tends to t l and t tends to int and l tends to l comma id and l tends to id. So these are the productions which satisfies this particular input string. And also we have to write the semantic rules first. Semantic rule. So as we said that only the value is not the attribute, okay, for the non-terminals. There will be a lot of things. So here you can see int is a data type. Int is a data type. So for this the attribute will be t dot type. T dot type is equal to integer, and for this also, okay, and here see a and b are identifiers. We know a and b are the identifiers, and what is the meaning of this particular statement? So declaration of two variables or two identifiers which are of integer data type. So here you can see t and l, t and l. So we have seen two types of attributes, that is a synthesized attributes as well as inherited attributes. So synthesized attribute means the value, the parent value will be depending upon the child values. So d value will depends upon t and l, but here you can see what is the l value, id. So this l value is id, and before reading the input, before reading the identifier, that should be of integer data type. So this completely depends upon the siblings. Okay, so here we are saying d as a parent, d tends to tl, and t comma l are siblings. So here l is an id, so l that is of integer. So l completely depends upon t. T is a data type, integer or a float or a double, whatever it may be, but it depends upon here. So you can also write t tends to int or float. Now you can say, if you consider identifier that depends upon the data type which is t, so t dot type is equal to integer or float, whatever it may be. And here l depends upon sibling, not a parent. So this is an inherited attribute. So we can say l dot inherited is equal to t dot type, because whatever the data type we are taking here, for that particular data type only the identifier should also be taken. So here the L value will be completely depends upon the sibling, not on the parent. So if the attribute depends upon the sibling, that we call it as a inherited attribute. So this is an inherited attribute. So inherited attribute. So in our previous example, we have seen the synthesized attributes. So in this example, we are seeing the inherited attribute. So here what happens? L dot in will also be depends upon the same thing. So t dot type, and we can simply add entry of id. Okay, add entry of id. And now we'll see the parse tree, how the parse tree will be. Okay, so parse tree, so what, first we need to start from the first production, d, t and l. Okay, and t is integer based upon this particular input string, and l again you can expand l comma id, and l id. Okay, and this will be a and this will be c, oh sorry, b. So int a b. So this is the parse tree. Now coming to the annotated parse tree. Annotated parse tree. So annotated parse tree means giving the attributes to each and every value. So we'll write here once again d, t, l, l, comma, id, id, int. Right? So now you can see we need to give the attribute values. So here int is nothing but a type, it's a data type, right? And t, the value of t becomes, so t dot type is equal to integer. T dot type is equal to integer, because here we are writing the data type, so we are giving the attribute as a type. And coming to here, so int is a normal int, the value of int is int. Okay, it's a keyword. Now coming to the id, id is nothing but a, and l, see, l depends upon t, so l depends upon this one. So in order to differentiate this one, I'll give l1. Okay, I'll give l1 instead of l. Both are equal, but just in order to differentiate that, I'm giving it as a l1. l1. So here you can see l inherited attribute is equal to l dot in is nothing but a type, because if you are giving any value to the identifier a or b, so that depends upon the data type, which is a this one. So l dot in is equal to t dot type. So this depends upon this one. Okay, so the value of l is getting from its sibling. So the same thing happens here also. L1 dot in is equal to integer. So because it's coming from its parent. Okay, it's coming from its parent. So L1 is also the integer. Okay, hope you understood. So this is a simple example for generating the annotated parse tree for this kind of input string. Okay, this is also an example for inherited attributes. So once again I'm saying, so here L is an identifier and the input string is a declaration part. So the declaration part means if you are declaring some variables, that should be done only with respect to the data type, what data type it was. So it totally the a value and b value depends upon the data type. So L value depends upon the data type t. T here is a sibling. So this is an inherited attribute. Okay, so previous example we have directly taken the values, that there is no data type there. Okay, but here we are having the data type, so it is an inherited data type. So in the annotated parse tree also, L value is getting from its sibling, so this is an inherited attribute, and this L1 value is coming from its parent. So this is a t dot type, this is nothing but integer, and this is a id is equal to, simply we can write id is equal to lex dot value, and here also id is equal to lex dot value, which is a here, which is b, right? So hope you understood. This is a simple concept, construction of annotated parse tree with the inherited attributes. So I'll stop here, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. If you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.